Hi there, this is session 32 of programming from the very basics using Python. This will be a shorter session compared to the other videos which I've created because I'm going to be focusing just on using the yield expressions. I thought of covering it in the previous session, but I didn't expect the video to spill out more than 1 hour, so I thought, okay, I will create a new session for that. So it'll be a separate session. So, anyways, here it is. What are yield expressions? You have seen me using yield statement in a function. So when you use yield statement in a function, the function is transformed into a generator. You can also use yield as a right-hand side expression. The same keyword can be used as an expression or as a statement. So here's an example which I'm going to show you and explain what it does. So let me create a function called testfn in here. I didn't select the kernel. Sorry about this. Let me just select the kernel back. Okay. So I create a function called testfn, but I'm going to transform this to a generator. But this time, what I'm going to do is I'm going to use print start of testfn, usual. And then I'm going to say v is equal to yield. Closely observe, I'm using yield not as a statement, but as a right-hand side expression. I guess you know the difference between statement and expressions here. The same keyword is reused here though, right? I say v is equal to yield, and then I'm going to just print back got value, v equals the value of v. And then whenever I use yield as a right hand side expression, I must couple this with a yield statement always. That's one of the rules for creating yield expressions. Otherwise, it may not work as expected. So I can just type v is equal to yield, and then I could just type yield. Maybe I'll just type v into v this time. Very simple example. Or let's make it more interesting. I'll just type maybe s is equal to yield to say that's a string. And what I'll do is I'll yield yes dot upper. Now, because I use yield statement and yield expressions, we use yield keyword inside a function as an expression or a statement. This function is transformed into a generator in any case. So you can just run this. It returns a generator object, which you can see here. Now, what is so special or what is peculiar about this generator is it works more like a consumer. The word generator is not apt for this, right? Generator is supposed to generate a value, but this consumes data, processes it, and then generates it, right? It takes in data, processes it, and generates it. Then how is it different than a function? Functions are run to completion entities. So you call a function passing an argument, it would do some computation, written out, and the function state is turned on. But here's an example which can maintain a state. Maybe I can also add something like this. Let's say I can say data is equal to an empty list here. So I'll just show you that it can maintain state across calls. And once I got this yield, let's say got value, and we'll just type maybe data dot append of s, s here. I forgot to mention this. S is equal to S. Yeah. And I'll also do one thing. I want to make sure that add another condition here. If not S, if S evaluates to Boolean false, right? It could be none, or it could be an empty string or zero, I think, right? In such case, I just want to return data. Return data. That's what I'm doing here. Now, when I run this, you get a generator object. G will be a generator object. To start this generator, as usual, you can say next.g. That's what you do when you put it in a for loop. When you call next.g, you can see that it starts executing till this code. Now you can see it written out. I mean, it came out to me, came out to us. I mean, to the caller. That is. So the moment you use an yield expression here, rather than yield statement, what is expected is that you need to feed value to it. How do you do that? This kind of a generator can understand a special method called send. Oh, it's not a function. Next is a function, but send is a method. So when I say g.send of, let me just type something like Alice. So when I say g.send of Alice, just see what happens. You can very well observe that what I send in as Alice is taken in by this generator. Technically, I should call it a kind of a coroutine, and represents it with the name S. Is labeled as S. It's bound to S, and then it prints it, which you can see here. Got value S is equal to Alice, and then what it did, it appends it to data. It checks whether S is equal to an empty string. If it's not an empty string, okay, I made a mistake here, did I? If not S, yeah, it's correct. Okay, if it's not an empty string, and this condition is false in this case because S is not an empty string, right? So this condition is false. It's going to append to a local variable which represents a list. It appends to a list represented by local variable. Sorry, so appends to a list represented as local variable called data, and then yields out the uppercase equivalent of that string. I can keep calling it multiple times. I can say g.send of Alice, g.send of John. So you can see it returns out the uppercase equivalent. Oh, I think it's a stop iteration. Maybe see what's wrong here. Oh, this must have been in a loop. Okay, I didn't use a loop here, right? This whole thing should go in a loop. I made a mistake. So what I'll do is I just for a while true, and then put this whole code in a loop because I want this to keep running over and over again. I don't want to put return inside a loop like this. This might look a little unstructured. Whenever you have a looping construct, my suggestion, again, this might be a little purist, so I'm trying to be very clear cut in this. So when I have a loop, normally calling return in a loop will return out from a function. But by looking at the function at top level, it may not be very obvious. So if you can, sometimes it's inevitable way to return out, you can use return. But in this case, what I prefer doing is I'll say break out of the loop and then explicitly return out in here. Return out from this loop in this place where I'll say return data, right? So let me run this. Maybe I'll not return data, I'll yield data at this moment because I need to yield out. I'll yield data. Let me run this one more time. It creates a generator, and as usual, when it says next of G, it prints this message, print start of testfn, and then it goes inside this loop, which is an infinite loop. The only way you can exit this loop is by this condition, which becomes true, which is when I pass an empty string, which breaks out of the loop, right? I just realized that you cannot use an yield expression as a part of, the Walrus assignment. The Python syntax grammar as of now doesn't allow that. So I just checked it out. So that's the reason why I had to use an explicit check and breakout. Otherwise, I could have said while s equal to yield as is, right? Using Walrus assignment and got this code working. But it actually raised a syntax error when I tried it out. So anyways, so it's the next of G. And you can see it says got value. It says yes is equal to none. Oh, okay. I think I ran this a couple of times, right? You can say stop iteration. Let me run this one more time. Normally, when you use a yield expression, first time you say next of G, you have to couple with send method. So when you say g.send of John now, you can see got value s is equal to John, returns John. So what happened was when I say send feeds data to this yield expression that's assigned to this local variable s is bound to that data, and now we can see what we got. And then this condition is not true. We append it to data and we yield out the uppercase of that string that we received, right? That's what this does. Again, I say s.send of maybe Sam. I think I should couple it correctly. So it's just like this. So when I say s.send of Sam, it doesn't do anything. I should call next send, next send. So let me do one thing. I will actually put both of these together. The next and send must be coupled. I'll tell you the reason why. The moment you call send, control goes inside here. And then when you call yield here, control comes back to the caller. Right? You should call next one more time so that the control goes back inside here to go back to this yield expression, comes back to us. We feed data and the data is read into S. Then again, control goes back. That means you need to couple next and send in order to work with this. The next is to let it go to the next iteration so it can come to this yield expression. And the moment you send, the sends return value comes through this yield. And now again, to go back into this particular code, you say next, which will go back into this code in this while loop, go to the yield expression, control comes back to us. Now we say send, control goes back inside, taking in the data, processes it, and then yields out. So you need to have this because there are two yield statements. Like you have two yields over here. One of them is yield expression, yield statement. You need to couple with a send and next, right? That's what you need to do. So let me rerun this again. I know that this is what yield expression is. Should you use it in your Python code? In production, to be honest, I've not seen anywhere this was used. At least in my experience, I've not seen this being used widely. It's possible you can use it. There are certain corner case scenarios where you want to implement a consumer kind of a thing or a filter kind of a pattern, then this could be useful, right? So you can start and you can see got value is equal to Sam. This time I'll just go back here and change it to Alice. Run this. It says got S is equal to Alice and returns Alice. But try maybe Jane. You get Jane. Let's try maybe Jonathan. Get Jonathan. To say I'm done, I'm going to send an empty string over here, or it could be a none. Both will evaluate to false. Once it evaluates to false, you can see it returns the entire accumulated list, which is there here. Which means it's like you have an object in which you are trying to feed data. It can do some processing and return back, but it can also maintain state across this calls. That's what this does. This is what yield expressions do, but I will show you another example. Maybe this can be more simpler than this code, right? I will leave this for your reference and experimentation and all that. So I'll show you another example here. Let us say that there is one function that generates Fibonacci series, right? So let's say one generator, let's say generates Fibonacci series. Let's say def fib of n. And then maybe here, let's say a comma b is equal to 0, 1. And as usual, let's say for underscore in range of n, I'm just going to type yield a followed by a comma b is equal to b comma a plus b. This is a generator because we use a yield there, which means that I should be able to say for n, or you can say for v in fib of 10, and I should be able to print v. I'll just print v as it is here for now. Now here's what I want to do. Here's a separate code that generates Fibonacci series. But now I need to also process this cumulatively, but I want to get a cumulative sum of each Fibonacci number that's generated. What is cumulative sum? I want to add 0 plus 1, then 0 plus 1 plus 1, then 2 plus 1 plus 1, then 3 plus 2 plus 1 plus 1, then 5 plus 3. I want to just sum them up cumulatively as values are generated. I got one number, create a cumulative sum, got another number, cumulative sum, another number, cumulative sum, and also generate that. The way I can do that here is this is a special generator that has to take in an existing input, accumulate it into a total, and also yield out the current total that is accumulated, right? So if you want to implement this kind of a feature, then you can do that. I'll call this as I'll call this accumulate for now, okay? Accumulate of n. Oh no, I don't need n here. Accumulate, and all I do here is that I'll just write maybe a while loop as usual, while true. I could just say maybe n is equal to yield, get a value to be accumulated. Oh, I need a total here. I'll just say total equals 0 for now. I'll say n is equal to yield, and then I'll just type total plus equal to n. Accumulate the total, right? And I'll also check if n equals 0. Do I need to check that? No, I will not set for any condition in this case. Okay, so I'll just say n is equal to yield, total plus equal to n, and then I'll just type yield n. Oh, yield total, sorry, yield total. The accumulated total, right, is going to be yield. So I have a yield expression where the control goes inside, a yield statement where the control goes back to the caller. Again, for the control to go back inside, I call next, and then there's a yield expression that control goes back to the caller. Again, to reach back, I have to call send so the control goes back in. So you have to couple next and send. Now, though I showed this manually, this might look a little confusing, but now I will show you how this plays out nicely the moment you start using a loop. So I say for v in, I say fib of 10, I say zip of fib of 10, comma, this is a little weird. This is a little weird. I'm going to use pip sum, accumulated sum, colon equal to, I could type accumulate like this. So I'm trying to do it in a one-liner. That's the reason I did this. Otherwise, I should have already called fib sum is equal to accumulate in a separate line above this for loop and pass fib sum as an argument. Because you need to construct this generator first, then you should call next on it. That's the reason I'm doing that. I can also avoid using this, but if I call accumulate, I will not get access to the actual generator object. I'll only get the written value of the generator, which is not what I want. I say v comma underscore. I'm not in, do I need underscore? Yeah, no, I'll say v comma, I'll just say maybe n comma, I'll say n comma t in these both. And then what I do is I just print n comma t here. I need to use one more parenthesis to close this. Now try running it. Oh, there is a none object. What really happened? Hang on one moment, please. Unsubvert operand for type, none type. Okay. What really went wrong? I think I called fib of 10. Accumulate. Oh, I made a mistake here. What I need to do is I need to call pip sum dot send. I forgot to put the send here. See, the for loop will invoke the next, right? But we need to call send manually. So I say send off, and I'll provide, I don't need this actually. This is not required here because do I need to worry about that? Let me just check. I know this is a little confusing, but just hang in there. I'll just type fib.send off, and I'll pass n, and I get the accumulated total here. I can print 10 here. I'll just use something else here. I'll just say n comma, I'll just use x for example. I'll try to print what x is. You can see the outcome of it. So it's from this, you know that you don't really care about this pattern as such, because when you call accumulate, you use yield total, but when you say next, control goes back here and there's an yield expression. When there's yield expression, control comes back to us, nothing is written. That's the reason why you get none here. So we don't really have to worry about this parameter. We can just leave it to underscore here. And now we can see the actual outcome as I showed you. You can see there's a cumulative sum being accumulated here. There's a 0, there's a 0, this is 1, 0 plus 1 is 1. Now when this is 1 one more time, it is 1 plus 1, 2. Now when it's 2, it is 2 plus existing value 2, that's 4. Now when you look at the next value being generated by the fib function or fib generator is 3, then you can see the accumulated sum is 7, which is 4 plus 3, that is 7. And you can see this is generating the cumulative sum as we go along. For use case patterns like this, you could use this kind of an algorithm. But though I just covered yield expression just to be more complete so I don't miss it out, is there a good use for this? Is there a way to do it without this? I would simply use good old for loop and, why use this complex accumulate function? If I want to solve the same problem on my own, I could have done this in this for loop as is, right? I don't need this accumulate at all. I could have rather simply said total is equal to 0 here and just called fib of 10. No need of all this complexity. I could just type n in fib of 10 And all I could have done is just print total plus equal to n, and then maybe print the total all the way here. This gives me the same output, right? I really need to use this complicated code to delegate that accumulation and all that. Everywhere I personally try to look at implementing yield expressions and creating some code separately and do certain things, then I realized, do I need to do that? I can do that without this complexity, and I can actually just go ahead and implement logic that's simple over here. Your mileage might vary, right? But this is what I found out personally, that yield expressions, though they look nice, I mean, you have a scenario where there's a producer, a generator that produces value, and there's another variant that will consume that value, process it, and produce it again, the transformed value, right? So such use cases, you might find it. If you're implementing even filter patterns, you can do that, but I am skeptical about it. If you want to implement a filter pattern, filters are what? It's like you can implement pipelines, filter pipelines, which is you have one particular piece of code which is generating values. You have another filter which takes in that code, does some filtering operation, generates something on the pipeline to proceed further. For designing patterns like that, I think it's better to use clean object-oriented code, in my opinion, which is more maintainable. This, as you know, the flow control itself can be a little confusing. Maybe many of you would have looked at this and I explained how this whole code works. The first one, most would have got it like, it's mind-boggling, right? Yeah, it boggles it, because you can see that there are two times control goes in and out of this particular code. The moment you say S is equal to yield, control comes back to the caller, right? Suppose if I have to show you by the execution here, maybe what I can do is I'll just copy this cell again. We'll see and try and run this in the Python tutor, and I will show you how the flow happens. Then you might have a little bit more clarity, but still it is confusing, right? So if at all I try doing this, if I just type, sorry, for underscore in testfn here. Let's say this time I have a list of names, right? Or a couple of names. Say users is equal to John, Sam, Alice, Jones, and maybe a couple of names in here. And then I say for underscore in testfn, because when you call testfn, it creates a generator. And on the generator, when you call next the first time, it stops here. And the return value is nothing. The return value is none. So you don't really capture the return value here. All you need to do is, once you're inside this for loop, you need to get access to testfn, and that's one thing. So you cannot, it can be like you have to use a Walrus assignment here, but otherwise you can use maybe t is equal to testfn this way, and then use for underscore in t, assuming that t is a generator. And now here you would use t dot send of users dot pop. Keep removing items from users and keep sending it across, right? I could actually use it like this, maybe if users t dot send of users dot pop, and I'll just get the result of this. And otherwise, you can just break out of the loop. I can print the result here. Oh, there's still an error. I think tuple object. Oh, okay. I think I use a tuple. That's a problem. So I think I can't use a tuple. I'm going to remove it from the list. So otherwise, you'd use parallel iteration again. Let's say for, u comma underscore in users comma t. You could also do that. I mean, zip of users comma t. I think I'll do that. It's better to this code got a little more complex. Just one moment. Let me just simplify it. u comma underscore in zip of users comma t. And then you could just use, you don't have to worry about all these if conditions in this case. You can just use r is equal to t dot send of u directly, and maybe I'll print r. I think make it more simpler. Now try running this code. You could see how this code works. Now the point is to understand the flow control, how the flow travels back and forth. Maybe what I'll do is I'll just copy this entire code and show it to you by putting it in Python tutor. Paste it in here and click on visualize execution. You can see that the program counter is pointing right here. It's trying to define testfn. You click on next. Testfn got defined. Now the next step would be to define users, which is a tuple in this case. The moment I say t is equal to testfn, t is now a generator instance, which you can see shown up visually here. The moment I say for u comma underscore in zip of users comma t, zip will do parallel iteration. Let's actually do two things. One, u will be set to the first element, that is John, and after which it'll call next of t. Next of t will kickstart the generator go inside this. I mean, it'll not go inside this. The generator is kickstarted anyway here. No, it's not. Sorry, it's just instantiated. Kickstarting the generator will go inside this code till it sees the yield expression here. We can see that happening right now. It goes inside this testfn, executes this, execute this line, execute this line, execute this statement. Now just see what happens when I click on next here. It's going to yield out this yield expression. Control comes back here. Now the control, when it comes back here, I'm supposed to couple it with send because the control came back because of a yield expression. So I had to couple it with send here. The moment is r is equal to t dot send of u. This u is John. That's going to be sent to t. So when you do that, the control goes back here where s will be equal to what you sent, and yield just pushes it into this code. And now we can see that we got value, prints s, and s is not empty, so it's going to append to data and yield s.upper, and it goes back here, prints this. Again, you can see the whole flow. Now you can see the control goes back here, continues the next statement after yield, goes back here, back in here. Again, our control comes back. You can see that for every yield expression, you couple it with send, right? See this. And now the control comes back to us, right? When you use yield statement. Now we need to couple it with next to go back inside this code, right? So you use next and send this way is how you see this code in operation. So this is what yield expression does. As I told you, it's not something that you want to use it on a day-to-day basis, but you would find some Python code that does have them. So if you see yield as, something is equal to yield, what the coder or the developer is trying to imply is that it's trying to create some kind of a filter, which means that it's a code. It's like a coroutine that's going to take in data after the generator is created by using some kind of send semantics, process it, and maybe yield out some written value. So it's for that particular purpose this yield expression is used. And that's about it. I think I'm finishing this video. It's a half an hour video, of course. So I'm going to finishing this video in here. So you understand what yield expressions are. Yeah, you can try it out, try to figure out, and you understand it. Very good. If at all you have any further questions or queries, or if you know any other use cases that you can think of for using this in real world in your code, you can also let me know. You can post it on comments. So if you really like what I'm doing, if you really like this video, just click on the like button. And yeah, if you already not have subscribe to my channel, to subscribe. I've created all the videos for overview of generators and function prototypes and so on in all my earlier sessions. If you have directly watched my video, this particular video as such, and skipped all other videos, do look into the other videos to build up the context. It's a flow that's coming on from session 1 till now. And I will finish here. So I'll meet you in the next one. Thank you very much.